Welcome to springlib.
So we essentially want to find the angle between these two vectors. We know that we can say the displacement vector from 1 to 2 is going to be equal to 0.230 I hat plus 0.133 j hat times 10 to the negative 9th meters. And then the displacement from 1 to 3 would be equal to 0.077 I hat plus 0.133 j hat plus 0.247 k hat, again times 10 to the negative 9th meters. So at this point, we can solve for the dot product. So the dot product between these two is simply going to be 0.230 times 0.077 times 10 to the negative 9th. And then we do that exactly for j. So this will be simply equal to, again, 2.03. So 0.230 rather, 0.230 times 10 to the negative 9th times 0.077 times 10 to the negative 9th. So it'll be the answer would be 3.54 times 10 to the negative 20th meter. And that's simply by multiplying these two x's and multiplying these two y's. We would multiply the z's, but unfortunately this vector here doesn't have a z component. And when you don't have a z component, that means that the dot product between for the z component between this vector and this vector will be equal to 0. So you really need to only do it for the x and y components. So 0.230 times 10 to the negative 9th times 0.077 times 10 to the negative 9th plus 0.133 squared times 10 to the negative 9th squared will equal 3.54 times 10 to the negative 20th meters squared. This will be the dot product between the two vectors. Now, it is good to find the magnitude in order to find the angle between them. So the magnitude of the first vector, 1 to 2, would be equal to 0.230 squared plus 0.133 squared to the 1/2 power times 10 to the negative 9th meters, and this is giving us 2.657 times 10 to the negative 10th meters. And then for the second vector from 1 to 3, we have 0.077 squared plus 0.133 squared plus 0.247 squared, all to the 1/2 power, and again times 10 to the negative 9th meters, and this is giving us 2.909 times 10 to the negative 10th meters. And then we can say that the dot product is going to equal the magnitude of the vectors, the product between the magnitude of the vectors, times cosine of theta. So theta will simply be arc cosine of the dot product and divided by the product of the two magnitudes. And we can solve. So theta is equal to arc cosine of 3.54 times 10 to the negative 20th. And then this will be 2.657 times 10 to the negative 10th times 2.909 times 10 to the negative 10th. And after evaluating, we find that theta is going to equal 62.7 degrees. So this would be our final answer for the angle between the two vectors. That is the end of the solution. Thank you for watching.